Hello and welcome to another one of my recordings. Through this recording, I'm going to cover some of the concepts covered in Chapter 7 of your book, essentially dealing with user-defined simple data types, enumerations, type defs. We'll also talk about namespaces and the string type. As far as this class is concerned, really from Chapter 7, I'm going to concentrate on the string types. So you won't be responsible for enumerations, type defs, and namespaces in homework assignments or exams. So we could have really ignored these items without losing any continuity in the course. But I'll go ahead and give you some overall basic ideas about these things. So the first thing I want to start with is the concept of enumerations. Essentially, enumeration means that you're creating your own data type. So in order to define an enumeration, then you need a name for the data type, a set of values for the data type, and a set of operations on the values. Now, enumerations have limited capabilities, so and you can do everything that you can do with enumeration with loops and ifs and conditions. So I'm just going to go ahead and go over a brief example, essentially, to show you how this stuff works. So I'm going to uncomment this stuff. Alright, so notice for example we use the reserved keyword enum, and then we create our type, grades. So think about grades as a data type with these values, A, B, C, D, and F, and these are, by the way, case sensitive. So if you use them all uppercase or lowercase or mixed case, you just have to be consistent in their use. Now, so again, you're saying that now remember that these are not actual constants. They're not like the character A, character B, even though they look like it. They actually look like identifiers or essentially variables. So they're treated as such. And so this is your definition of enum, of the enumeration. And then just like you create any variable like int x, so for example, if I wanted to define a variable x to be an integer, I would use int x. In this case, I'm using grades, which is my enumerated type, followed by a variable of my choosing. Of course, this could be any identifier that you like. So that's how it works. You create the enumeration with these values, and then you can create any set of variables. Of course, you can also create an array of these grades or enumerations if you wanted to. Now notice that the way we assign values to our enumerated types is essentially the name of the variable that you created. Let's say in this case my grade equals to one of these items. So I say my grade equals to B. Now remember again, if I wanted to assign a a grade of someone to the letter B, I'll probably just use a char or a character variable type, and I don't even have to use enumerations. And the way these works, again, essentially is the positions of these enumerations are important. So this is at position 0, position 1, 2, 3, and 4. So when I when I write out my grade, it doesn't actually display the grade B. It actually it tells me the position of that grade in my list. So B is going to be at position 1. Now you can actually do some operations on enumerations by casting. So if you do a static cast grades, my grade plus 1, all I did was I changed my grade. Essentially, I changed the position of my grade to the variable identifier C. So position here is going to be essentially it was 1, now it's going to be 2 because I upgraded my grade. So you can't just add 1 or subtract 1 from enumeration, you have to cast it. Okay? So when I say my grade equals to A, then I reassign my grade to A. Now, in order to actually display values of enumerations, or essentially what's in them, you actually have to use an if statement. So you say if my grade equals to 0, then it must be an A. If my grade equals to 1, remember these variables, these enumerated variables, are only holding the positions. Enumeration color, red, brown, yellow, green, and then you say color my car and his car. So now I've created two variables. Notice here I've created an array of cars. So again, the idea is that all of these variables have access or enumerate or have these data types. So again, my car equals to green is a little bit more readable. And this is what I meant by these things being case sensitive. They don't have to be all in caps. It's just that if you type lowercase green in your enumeration, then you just have to use it as such. Okay, so if I ran this thing, then it's just going to give me some essentially assignments and outputs. So that's it. So let me just go ahead and run this thing, and we'll go quickly through this. Again, I don't want to spend too much time on enumerations. So it displayed position was 1, because remember my variable was B. So now it's that. And let me go ahead and minimize that. Position was 1, then position became 2 because I added the enumeration, I added 1 to it, changed my grade to an A, and then I said if my grade is 0, again you have to check for positions and then do the output. Similarly, if you had to input values, it would be similar to you have to use a switch or an if statement to do that. So color on my car is 3. So what was my car? It was green. 0, 1, 2, 3. And then looks like here I'm making all my cars to be yellow. So that would be 0, 1, and 2. And that's why it displays all the 2s in there. Okay? So again, you can display the value, but if you actually wanted to display the color, you have to do a switch or an if to make sense of it. Okay, so I'm going to go ahead and close that, and that's really all I want to cover on enumeration. So if you're interested in doing this, reading more about it, just read your book. The next thing I want to talk about is the type defs. So I'm just going to scroll over enumeration types. Again, all these examples are good examples. So you can also, by the way, you could check, use relational operators because they're positional. So you can always check to see if, in my example here, know that red is less than brown because red appears before brown in this list. So let's go ahead and get to the next topic, which is type defs. Now, type def is another one of those things that you may not really ever use, but essentially all it does is that you actually create a new variable from an existing variable. You don't actually create a new variable, a data type variable. You actually create an alias or a pointer to it. This is good if you are dealing with, working with other languages that may use different names for their data types. For example, you know that in C++ we use int for an integer, but some other languages use the word integer or the actual keyword integer to define an int. So what we could do is we could say type def int to be an integer. That's all, really. So this is really for compatibility with other languages if you ever had to write code to do that. So that's it, really. So if I go in here, notice I'm just going to undo this just to show you what's happening. So I say type def int integer. So from now on in this program, instead of saying int test or int x or int y, I could also say integer test. Of course, I can still use int if I wanted to. So notice I said type def and an integer. From now on, integer is a pointer to an int. It's an alias to an int. So this is just like me having said int test equal to 1,000. So of course, it works exactly the same way. So if I ran this, I'm going to get 1,000 as output, which is what we expect to get. Okay. So I comment this line out too. So type defs, again, not very useful in most cases. But again, your book covers a little bit about it. Now, the other thing that your book also talks about is this concept of namespaces. Essentially, with ANSI standard C++, after July of 1998, they introduced the concept of a namespace, which is essentially a way to deal with global variables. So, and we've been using namespaces, and I think I told you back in the beginning of the class, when we include IO stream, IO stream includes the definition of some of the global, essentially, functions, such as cout, cin, endline, ndl, ndl. They're all defined in IO stream. Now, if I don't specify using namespace std, by the way, std is a namespace that's defined in the IO stream header file. So if I don't do this, if I don't say using namespace std, notice what happens. Right now, this program, if I run this, and it's just going to give me hello. If I go in here and just comment this line out, now std, of course, is included in IO stream. But for C++, to be able to use cout, you now have to specifically refer to that namespace. Again, as soon as I give you another example of creating a namespace, hopefully that will make a little bit more sense. So when I comment this line out, when we get to this cout, the compiler isn't going to know where cout is coming from. So notice where I do a compile and run, I will get an error message saying that this is undefined. So what we do is we use our scope resolution operator, a pair of colons. So we say std colon cout, and of course you have to do the same with the end line. So I could do this, and this should work just fine. So that will give us hello. So I guess if you don't want to keep using this annoying namespace, all you can do is go back in here and say, well, use the namespace std so that I don't have to do this anymore because it's global to this main function, and then I could just use it without it. So notice if I uncommented that and I'm going to run it, this is still going to work. I mean, the std using the resolution operator with the std is going to work just fine, but it's just not needed. So that's really the definition or the idea behind namespace, is a way to resolve global variables. Remember, the global variables are variables defined outside of your main or outside of your other functions. Okay, now here what I've done is that I've given you actually an example of creating our own namespace. So notice I'm saying namespace company. And by the way, we use namespaces a lot of times for global functions and global constants. So notice I have a const string name, a CSN, and then int number of students, 40,000. And we usually put using namespace right after the definition of the namespace. But it doesn't have to be. It has to be after it. It doesn't have to be immediately after the definition. Remember that this could actually be included in a header file, which we'll have to include in a project. So technically, you can't even see this. It will be in another header file. We just tell our users what namespace to use. So given this, I'll go in here, and I have this example here where I have right here, I'm going to do a cout name and number of students. So I'm displaying name, so I'm going to execute this program. And name, well, hello, remember it comes from that first cout. So the name is CSN and the number of students were 40,000, just because name and number of students are global in here. Now remember that if inside your main or any other function, if you redefine your variables like name and number of students, then those redefinition will take precedence. So again, the idea is not to use the same variable name in your namespace as you would in your main or other functions. Okay, so notice that if I just took this out and just said, don't use the namespace company, I should get an error message because it can't resolve name. essentially is looking at name in here in your main program, and it says I can't find it. And again, if you had a definition for name right there, no problem. It just wouldn't be CSN, and the number of students wouldn't just be 40,000. So notice that as soon as I do that, if I don't use namespace, you do that. Now, with the same token, of course, you're going to tell me that, well, can we do this? Can we just use the scope resolution operator to specifically look at the company namespace? This is the same as the STD namespace that we just talked about. Scope resolution, name, and number of students. And of course, this should work because we are actually globally resolving that variable in our namespace. Okay, so that's what I meant by the fact that imagine an I/O stream. There is a namespace STD, and it's got all the definitions. We include it, and we just say we'll use it so that I don't have to keep using the scope resolution operator. So I uncomment that, and of course I'm just going to comment this because I don't need this stuff anymore. And that's that. Okay, now finally, so if I go back to my, so that's essentially, if you read your book on namespaces, they'll give you an overall idea of these global identifiers and the use of namespaces. Okay? So the most important thing in Chapter 7 is the string type, which is a special type because it actually contains a whole bunch of functions. Of course, the strings are useful because any text material could be treated as a string of characters. So C++ gives us the opportunity to use this special string data type that gives us a whole bunch of essentially functions that we could use with it. Remember that a string is a sequence of 0 or more characters. The first character is in position 0, and then 1, and so on. Now, essentially, this string is an array of characters, which we'll cover in a week from now. But again, it's really this bracket. Subscript operator, we'll talk about that when we discuss arrays. But for now, just remember that if I have a string, for instance, in this case, when I say string str, I'll go ahead and uncomment this. So when I say string str equals, by the way, we did see strings back in, I believe, chapter 2 or 3. So when I say str is hello world, all I'm saying is that str is a sequence of characters that start at position 0, so H is at position 0, E is at position 1, and so on. So when I say cout string, it's just going to display hello world and of course the end line. Now notice the string has a function called size. So I could use the size function that tells me how many characters are in the string. So imagine, of course, anytime you see a constant like this, you can actually ask the user to input a string, or even better yet, you can actually read strings from a file. So if you're given a file and say, hey, can you find the length of each line, you should be able to do that. So a string.size with a pair of parentheses. And by the way, notice the use of the dot operator, which comes in handy when we talk about the object-oriented programming design, which we don't really actually cover in this class, but at the end of the semester I'll have a brief lecture on OOP, or object-oriented programming. But again, that's how it is. If because a string essentially is a class or an object or a class of strings, you could use the dot operator to access its members, which in this case would be size. So size gives us 12 for the number of characters. Notice I have a substring or sub str, which you provide the starting position and the length of the string that you want to take. So all you're telling this is start at position 0 and give you 5 characters. So that's going to give you hello. Again, your book gives you a list of a lot of functions that accompany the string class or the string type. And what you need to do is make sure that you understand how to use these functions to essentially do your work. Notice I have a variable called spacelock, and there's a function called find. And as you may have guessed, what I'm trying to do is I'm asking C++ to call a function named find on the string hello world and have it come back with the location of the space. So as you might expect, the location of the space would be 0, 1, 2, 3, 4. I believe it should be 5, which is right there. And then you say, give me a substring from 0 up to 5. So, or not up to 5, with a length of 5. So as you might expect, this gives me exactly the same as this one. It's just going to give me hello back on the screen. How about the 0 and a large number? Well, if this length is larger than the length of the string, it's going to go from the beginning all the way to the end. So it's not going to crash or anything. It'll just give you whatever it has. Well, you probably guessed by now. Find comma is just going to give you the location of comma. Now, if you can't find the location of the comma, what C++ does is it will give you a constant, essentially, that's associated in the string class, and that constant is like 4 billion something, which is the size of an integer, the largest integer, a 32-bit integer. So if essentially all we're saying is that if you ask for a character or a string, and the string does not exist in your master or your source string, it's going to give you this endpose. Notice then I could use that, so I could say if comma lock equals to string colon colon, so hopefully by now you know what this means, right? So you have, imagine the string data type or string namespace that has a constant name endpose, and I'm using the screen resolution operator to access that. So you say string endpose, and then so we're saying if comma lock equals to that, you're simply saying, well, I can't find the comma. So essentially, if you're looking for a character or a string, and it comes back with the endpose value, that means it couldn't find it. Now you have a string fname and lname. Fname is Joe, lname Smith, and fname dot swap lname. So as you might have guessed, there is a function called swap that essentially changes the first parameter with or the first variable with this variable. So when I print this back, fname becomes Smith and lname becomes Joe. Not that you really want to do that. Here's another example where I have a string phone. This is a typical phone number with parentheses and dashes. And let's say I want to extract the area code. Well, I know area code is 3 characters, and it has to really start after parentheses. Or maybe I could just assume that the position is always 1 because that first one is position of 0. Now, remember with this, I'm assuming that the syntax is like that. In other words, you always start with the parentheses. But as you might expect, can I go ahead and find the location of open parentheses and then put my beginning position at that location plus 1, so I will start with the next character. So you could do that. So it all depends on how you want to parse or treat that string. So area code is phone dot substring 1, because I want to start at 1 and go a length of 3, meaning give me 3 characters. So that gives me 702. I want to find the location of dash, so you've done that. By the way, right here, notice I find the location of dash, and I do a prefix, phone.substring dash plus 1. You want to go up there, up to 3 characters. Now, do you think we should actually check to make sure the dash is not the same as endpose? Because if it is, you can't find the dash, and if you can't find the dash, you probably want to tell this user or print out the fact that you can't identify the prefix of the phone because the format is just not correct. So again, anytime you use find, you probably want to check the value returned by find to make sure that it's not an invalid value. In other words, make sure that it is found in your list. So in this case, I'm just assuming that, yeah, it's going to be there, so I'm going to go -1, so it gives me the 6, and then again 3 characters. Now I'm going to look for the position of the last dash. Now notice I can use find with a string and then tell it where to start from. So find essentially is an overloaded function, meaning that it's able to be run with 1 parameter like this or 2 parameters like this. So you're saying start at the old dash +1 right there and then look for the dash again. So of course it's going to give you this one. And then I say give me the substring from last dash +1, which is 5. And in this case, notice I didn't specify the length. And I just said if you don't specify the length or give it a very large length, it's just going to read all the way to the end of the string. So I'm going to get my correct phone number or P number. So let's just go ahead and run this, and of course I went through this with you, so hopefully you can go back and double check and make sure. Notice the area code is 702 and all that. Okay, so that's one way of essentially dealing with strings. So when you look at your slides, you'll notice that they talk about this additional string operations, the string size type, and the string endpose. Now, the size type essentially of a string, think of it as a special data type. So some compilers may complain about the way if you define the variable size as an integer, it might complain and say, well, I don't understand that. Usually they just give you a warning. So essentially, if you want to define the size variable, we actually use a size type as just like an int or a. Of course, you want to use a whole number data type like an integer or long to represent that. And remember, the endpose is just a maximum value. It's a named constant that you can use to your advantage. Okay, so this is an example of the swap function that I just talked about, and then of course this is a summary of what we discussed. So hopefully this was helpful. Again, I highly suggest that you go to your book and read about some more about the string types. And of course, when we get back to arrays, in a couple of weeks or a week when we do arrays, we'll come back and talk about string types, because then we can treat a string as an array of characters, and we could do a lot of good stuff with this data type. So I'm going to go ahead and stop right now, and hope this was helpful. Goodbye for now.